Hello once again and welcome to this session on decoding the science of decision tree. We are going to discuss about a technique called decision tree, which is part of data mining supervised learning, right? All right. Okay. Seems like that was an accident. Accidentally, Atul might have raised his hand. So here we go. So this is the agenda for today's session or 1 hour webinar. We're going to discuss about classic business problem, which is related to banking industry. What do you think, guys? What do you think? If you have already guessed on what is the problem that we're going to discuss today, anyone? What is a classic banking challenge related to loan? If I give a loan to someone, what is a classic problem which banks face? Provide a loan or not? Absolutely, Arun. So that's a classic problem that we actually, they don't pay, fraudulent, right? They default the loan, things like that. Recovery, yes, absolutely. You all are on the same page, basically, right? So we'll look into the bunch of credibility of the customer, Praveen, absolutely. So the available options for solutions. What are the various solutions available if I have this kind of a banking challenge problem? Why do we need to use decision tree? Why can't we use some other technique, right? So we'll compare decision tree against few other techniques. And we are also going to discuss about decision tree methodology, whether it's going to work or not, how it's going to work. Okay, so let me move on to the subsequent slide. So these are the various classic situation problems in banking or financial services sector, right? Whether a person is going to default on the credit card, should I even give him a debit card or not? Is he going to default on the loan or not? Will he or she become a fraud transaction or fraud customer? Yes or no? Things like that. Here is a typical problem. A bank wants to classify its future customers into two segments or two categories, basically risky or good. And based on various attributes such as whether a person has an undergraduate degree or not, based on the marital status, whether a person is married or not, taxable income, city population, work experience, whether a person stays in urban area or not. Based on all these attributes, we want to classify a customer as a risky customer or a good customer. How will a bank know whether a person is risky or good? That's a problem that we're trying to solve here. So if a person applies for a loan, right, should I approve a person's loan based on whether a person is good or not, right? Or if he's a risky, I'm going to reject the loan. This decision tree can also be used in multiple other situations or scenarios, such as, should I hire a person or not? Should I invest money in hire a person or should I not hire a person? Should I go with, say, venture capitalist A funding or should I go with B? Should I purchase iPhone or should I purchase Samsung? Will a person actually leave my company, yes or no? Right? Will a particular customer move from Airtel to Vodafone? Move from one telecom operator to another, yes or no? All these are the typical classification problems which can be solved using decision tree. However, are there other solutions available here apart from your decision tree? That's the question. Oh yes. We don't just have decision tree, we have a bunch of other techniques also. And those techniques are naive Bayes, KNN, support vector machine, and the list would only go on and on. So we have a lot of techniques available for classification. Let us compare these four and check on why decision tree is superior in comparison to the other techniques. Here we go. What are the various advantages of decision tree methodology? TT means decision tree, NB means naive Bayes, KNN, and support vector machine. simple visual representation of a decision situation. So you can actually view on what's going on while you actually run this model. When you actually execute this in R or any other tool for that case, you'll actually be able to see the outcome. You'll be able to see what's happening there. That's decision tree. Your Canon, Naive-based, SVM, these are kind of black box models wherein you'll not come to know exactly on what's happening in the back. So no visual representation for these. However, decision tree has a visual representation. At the end of this presentation, we will actually run the R code and see how it works. It's easy to interpret and explain to executives. If you have non-programmers, people who do not understand the programming aspect, decision tree would be the best bet. That's considered to be extremely simple to explain, interpret, and explain to your non-programmers, people who do not understand your non-programming, people who do not understand your programming. It illustrates a variety of decisions and also the impact of each decision if different decisions were to be taken. I'm going to explain about this third point in the next slide or so. And allows us to predict, explain, describe, or classify an outcome altogether. That's only done using your decision tree. And it will help you demonstrate various scenarios, such as what is the best case, worst case, and what would happen if I consider a few of the attributes, basically. And the good part is that this can be used to handle both your numerical as well as categorical data. Right? So your decision tree is white box, meaning you can clearly look into your outcome in a visual way and see what's happening in the backend. However, the other models are called as black box because you cannot really read what's happening in the background. Let us consider this small example to understand the what if scenarios which can be done using your decision tree. You have a manager you want to hire, right? Either you want to hire a permanent position or you want to outsource a piece of work. If you go for a permanent position, the person whom you have hired can either stay for 6 months with the company or he might leave, right? He might leave before 6 months. If a person stays for 6 months, right, then there is a 50% chance of success and you'll be gaining $100. So this is called as probability, 50% success here. This is your probability and this $100 here is your impact. Right, so you multiply probability by impact to get a value there for the success. And if you go for a permanent position, your project might also fail. What is the probability of failure? Say the probability of failure here, for instance, is 50% once again. And what would happen? What would the impact be if your project fails? Impact is that you would lose $40 basically. So if you subtract these two, you'll get $30. Right? This is one scenario. Let us look into another scenario. If I outsource a piece of work, my project might either succeed or fail. What is the probability that your project might succeed? You have 50% chance. And what is the associated impact here? $90. If you outsource a piece of work, your project might also fail. And there's a probability of 50% that your project might fail. And you might lose $20. So in all these scenarios, one second, let me erase everything. So if you look into these two scenarios wherein you want to hire a permanent position or you want to probably outsource a piece of work, right? And if you outsource a piece of work, right, or if you outsource your project, $35 is what you might get, right? If you go for a permanent position, you'll get only $30. So based on these two outcomes, final outcomes, after looking into the probability and impact of success and probability and impact of failure, you would obviously go with the second decision of outsourcing the work. This decision tree, simple decision tree, can then be used for your data mining aspect also. Your decision tree is a supervised rule-based classification. You'll set some rules and then classify people, right? So the topmost node is called as the root node. And based on that, based on the decisions that you take, for example, your outlook is whether you want to play a particular sport, yes or no. Whether you're going to play a sport or not is going to depend on whether the climate is sunny or whether it's rainy or overcast. If the climate is sunny, then you're looking into yet another rule, another split, which is called as your intermediate node or your split node. If it's sunny, you're also checking for humidity. If it's very humid, probably you do not want to play. Do not want to play or you want to play is a final decision, and hence it's called as a leaf node or terminate node. And whether you want to play or not, that's the root node. You're checking whether the climate is rainy or not. If it is rainy, you'll stop there. You're not going to play. Sorry, you're going to play. Yes, that's it. There's no further split associated with this. However, if it is overcast, you're checking for another rule on whether it is windy or not. If it is windy, you're not going to play. If it's windy, probably. Yeah, if it's not windy, you're going to play. If it's windy, you're not going to play in that sense, right? So the final nodes are called as your leaf nodes or terminate nodes, wherein you have taken a decision. The intermediate nodes are the nodes based on which you're going to further split your decisions, right? And this is called as a typical classification rule. For example, should I play, right? And what is the first classification rule? It's sunny and humid. Humidity is high, right? Then you are not going to play. If it is sunny and if the humidity is normal, you'll play. If it's rainy, this is the third classification rule. Rainy, you'll play. The fourth classification rule is that if it is overcast and if it is not windy, then you'll play. That's the fourth classification rule. And the fifth classification rule is that if it is overcast and if it is windy, you're not going to play. In this way, you create a lot of classification rules using your decision tree. And as and how you move down this decision tree, you're going to split further based on the multiple attributes that you have. Take the example of this decision or the problem wherein we want to classify a customer as risky or good. So here is the historical data which we have. We have the details on whether a person is an undergraduate, yes or no, whether a person is married, single or divorced, taxable income, right, city population, work experience, urban, yes or no, whether a person is from an urban area or not. And based on all these things, this is the historical data which you already have with you, which the bank has already collected, right? So based on that, you have the historical data and the category, right? Whether a person is risky or good. In the past, say you have allotted loan to a person, you have given loan to a person, and he was an undergraduate married with this taxable income, the city population, 14 years of experience, and not from an urban area. This customer, say he has defaulted your loan, so he's a risky customer. You have already got this information from historical data. If There is a person who is not an undergraduate, single. This is the taxable income, and the city population is given, work experience, and he is from urban area. So given all these attribute values, this person has paid you the loan on time. He has not defaulted, so he's a good customer. And in this way, you have a lot of historical data available. You are going to build your decision tree model based on this historical information. And once you build the model, whenever you have a future situation, right? There is a person who walks into your bank, he applies for a loan, he has an undergraduate degree, he is divorced and has taxable income so much, city population. He also has 14 years of experience and is not from the urban area. How would you classify this new customer? Would you classify this new person as risky or as good customer? That's the problem that we have, right? So we have a historical data. We have built the model using decision tree algorithm. And then whenever there's a new situation or scenario which arises, based on that, I can categorize the person as risky or good. Right. At this point, let me see what are the questions that I put. Arun has this question: are decision tree, naive-Bayes, KNN, and SVM algorithms? Absolutely, Arun. All these are the various algorithms within your data mining supervised techniques. Right? We can make even SVM and KNN on graphical form, is what Kumar Swamy says. Interesting. So, does your model show that outcome in a graphical format as what your decision tree shows, Kumar Swamy? I'm not speaking about the explanation. I'm speaking about your R or any other tool. Or does it give you the final outcome? So let me show you that. Let me show you that, Kumar Swamy, and then you can counter me if you have any questions. Right? Using which tool are we going to see decision tree, Arun? Arun, we are going to look at this using R. Using R. So let us proceed further. So how it works, right? Let's build a decision tree. So you're going to first choose this root node, and we have, for our understanding, chosen this root node as undergraduate. Now my question is, why did we select undergraduate as our first root node? Because here we have a lot of other attributes like such as undergraduate, marital status, taxable income, city population, work experience, and other. If I have 6 attributes, why am I selecting undergraduate? Is it because this is my first variable or first column there? Is that the reason? Can someone just comment based on your understanding? Okay, I'm not seeing any answers, so yeah, there we go. It may be the least age. Rajit says maybe it has 2 possibilities, yes or no. Praveen says it may be the least age. It says yes or no is what Sheikh says. Um, that is sensible for the situation is what Kumar Swamy says. Education directly proportional to income. Okay, is what Arun says. It has the least variance is what Nihal says. Easy to classify, but so does Urban, right? That's the minimum qualification and all that. Yes or no. Okay. Tapan also says that it's yes or no has 2 answers. But the right answer to this is there is something called as entropy and information gain. And information gain. right? So these two are statistically calculated. I'm not going to get into that detail because 1 hour might not be sufficient otherwise. So using these two, how much information are you gaining if you split or if you consider undergraduate as your first node? How much information do you get if you choose marital status? How much information do you gain if you choose taxable income as your root node? And how much information do you gain if you choose either city population or work experience or urban, right? As your root node. This is mathematically calculated in the backend, right? You can also manually do that calculation. It might be a little tedious, but yeah, you can manually also do these calculations. And the attribute or the variable which gives us the maximum gain, that is the attribute which is selected as your root node. And in this case, it happens to be undergraduate, this attribute. And in undergraduate, you have 4 good and 3 risky people. So let us see here we have 7 rows. And if I select yes as undergraduate, 1, 2, and for both of these two, I see it's risky. And also if you look into undergraduate, right, and the corresponding categories, you have 3 risky and 4 good. So I move on. We have 4 good and 3 risky. And undergraduate, as you all have rightly seen, you can either split it as yes or no. If I split it as yes, the values corresponding or the entire row corresponding to undergraduate yes is listed down towards the right side against yes, and wherever you have the undergraduate value as no, you have all these corresponding rows. So I have 2 yes, and the entire row corresponding to your yes and corresponding to your no is taken here, and wherever you have yes, this is information pertaining to that, and wherever you have undergraduate no, these are the rows pertaining to no undergraduate, right? Now what do? We classify the customer as risky or good, right? Here if I have both of these things, both right as risky, I'm going to stop. I'm not going to further split this. I am going to split only if I have different categories, different outcome categories basically. Here I have good and risky. So I need to further split this. If I were to further split this, am I going to use marital status or taxable income or city population or work experience or urban? What am I going to choose here, right? Once again, information gain or the gain value, which we have calculated earlier, right? We should have ideally calculated earlier. That comes into picture. After undergraduate attribute, which variable or attribute gives us the maximum information gain? That is chosen for the next split. It's not marital status just because this is the first variable now. No, it looks into marital status, taxable income, city population, work experience, urban, all of these, and then it's going to further split the node, right? This is called as a pure subset because both of these are risky. Here you have 4 good and 1 risky, so you can split further. Right, I'm splitting further based on marital status. And in marital status, I have single and divorced. All the values related to single, all the rows corresponding to marital status single is listed down here. All the rows corresponding to divorced is listed down here. Right? And I'm not going to further split this marital status divorced table. Why is that so? Because both of these rows have good as category and it's a pure subset. However, if you look into single here, you have good and risky, so I need to further split this. Once again, the information gain comes into picture. Out of these 4, sorry, out of these 4 variables, which is taxable income, city population, work experience, and urban, which variable or attribute gives me the maximum information gain? That is selected to split this further. So here we go. Since this is pure data set subset, we are not going to split that further. Since here we have good and risky, we're going to split this further. Here, once again, the third split is based on taxable income, just because taxable income variable gives me the maximum information gain after your marital status. So again, I've split. Since I have only one category here, I do not have any further split. I'll stop here. Since here I have same category, I'm going to stop here from splitting further. And these two are also called as pure subset. Now, here is the model that we have. Undergraduate, yes, no, single, diverse, and we got this classification model, right? How did we select this first node as root node based on information gain? Why did we split on marital status next? Because this is the next variable which has given us a maximum information gain and taxable income, the third. Your model, your R or any other model tool that you use is going to throw you this kind of a representation. So Kumar, okay, Manish has this question. Is there any thumb of rule on how to arrive at decision tree? I mean, saying 6 to 7 end steps. Manish, the same explanation. Hope it answered right. 6 to 7 steps. Take your historical data, split it based on your variable which gives the maximum information gain. Split it till you arrive at a pure subset. And Kumar Swami has this question: how to make machine learning from decision tree? In this context, what exactly is the meaning of machine learning, as this is just based on if then else conditions? So Kumar Swami, machine learning means you have only 7 data points when you build this model. As in how you get more and more customers, you keep adding that data to the already existing data that you have, and you further refine your model. Once again, you do decision tree. Once again, you do decision tree. So as in how you get more and more data, your classification would become so much more accurate. Arun says, is there a formula for information? Absolutely, Arun. There's a formula for information gain. And you know, there is something called as entropy that you calculate, something called as information gain. You subtract those two to get the gain. So it's slightly, I would not say very complex, but slightly complex formula. How do we fix the income as 33K? Based on your domain knowledge, domain experience, Shanta. Maybe for that particular bank, based on your domain experience, you feel that median is 33,000, right? Or majority or mean is 33,000 if you do not have any outliers. Based on some descriptive analytics, elementary analytics, you arrive at that, but it has to be backed with your domain knowledge. Any useful links, video links for the same? Or you can just Google that decision tree, entropy information gain formula, you'll get that. It's just simple, straightforward calculation. Manish says, no, what I mean is it possible that I take 4 steps and someone takes 5 steps to arrive at decision tree? Yeah, it can be possible, yeah. Based on what tool you're using and all that, it can be. And each time you run a model, decision tree, each time you execute the command, you might get a different representation. That's absolutely fine. But your model will get enhanced over a period of time. Yeah, it's just generation of classification, Kumar Swami. That's it. However, it's not that straightforward on you just create classification rules, right? And the backend there are some calculations which go on based something called as entropy, something called as information gain, and you subtract those two to arrive at another value. Greedy algorithm is what we call that. So it's not as straightforward as you see it here, but in the backend there are a lot of calculations which go in. Anjali has this question. In case the information gain of 2 or more attributes are same, can we then randomly pick any attribute? Yes, Anjali, that is what exactly happens. Abhilash has this question. There can be many decision trees for a single problem. Absolutely, Abhilash. There can be many decision trees. But which decision tree is the most optimum for you? That is what you're any tool that you use, statistical tool is going to tell you. How do we determine which is the best tree from among various trees? Kalyan has this question. Hey, Rajit says he's not able to hear me. Are you guys able to hear me? Please confirm. Yeah, all right. All right, Rajit. So, okay, thank you. Kalyan has this question. How do we determine whether which is the best tree from among various trees? So, as I've been telling you, how do you select the root node? Based on the information gain, right? There's something called as information gain which gets calculated. So this root node would be, you're going to select only one attribute as a root node. There won't be multiple such nodes, right? Or you cannot select marital status instead of undergraduate. You cannot select taxable income. There is only one. So ultimately, when you execute this particular algorithm in any of your statistical tool, you'll get only one outcome, only one decision tree. All right, Kalyan has gone offline. So let us move on further. Let's use our model. So now here is a new situation which I have, new entry, new data. There's a person who walks into my bank. He says he's not an undergraduate. So no means I take this route. Divorced. So marital status, I see whether single or divorced. I see that he's a single, divorced. I know for a fact that I need to categorize this person as good based on what? Based on my model. My model is built on what? My model is built on the historical data, the true facts which have happened in the past. It's not based on some assumption values. It's based on the data which I've seen in the past. So if a person has an undergraduate degree and the marital status says he or she is divorced, then the category would be good. So I'm going to categorize this person as first of all, undergraduate, no. Marital status, divorced. What is the outcome? Good. So you are going to classify this person into a good group, and he can be considered for all policies for a good customer, such as lending him loan at a lower interest rate, giving him credit card, increasing his credit card limit, so on and so forth. All these decisions can be taken. Manish says this, is there a guideline that there needs to be X number of records for model to be reasonably robust? There is no exact thumb rule as such, Manish. More the data points, better it is for you. But I would say go ahead with 30 data points. 30 data points initially. Based on that, select your sample size. Based on the formula which says n is greater than 10 times of your kurtosis square, or n greater than 10 times of your, skewness square, or mod of kurtosis. So there's a lot of thing around your sampling and population, right? What sample makes a good assumption for me to proceed with building this model. So general thumb rule is go with 30 data points and then start using that 30 sample, calculate the skewness and kurtosis for those 30 data points. Based on that, come up with revise the sample size, which will actually help you come up with a better model. So that's my answer to Manish. Then how do we arrive at the confidence level of critical region? So I think you're looking into this as a regression, right? This is not regression wherein you have one number, Manish. This is classification problem in data mining wherein you just say yes or no. There are no numbers associated with that. Whatever value outcome that comes is yes or no, good or bad, good or risky. Whether a person is going to be defaulting on the loan, yes or no. Attribute data, absolutely, Abhilash. Shravani has this question, based on which factors we will decide whether it is on the good category or risky category? Based on the same thing, right? Based on various attributes. You have already built a decision tree. So this is your decision tree, which your model has built, which we have built, right? And based on this, Whenever you get a new value, you check that or validate against this, and then you go ahead with the outcome. Abhilash has this question. If there are many attributes for big historical data, there do we have to calculate the IG entropy for each attribute? Absolutely, Abhilash. We have to. Gaur has this question. If you have historical data of particular bank for last 10 years, is it going to increase the validity of model or make it more complex? So, Gaur, this is what happens, you do not go back and collect so much of data. It's good if you have so much of data. But the banking policies 10 years back might have been different. The living conditions of people in a particular geography might have been different if you go back by 10 years, right? Probably now things are different. So a segment of people who used to default 10 years back, probably now they have changed their lifestyle, things like that. So it's good to use the latest data, all right? And that is the reason it's called as machine learning. 10 years from now, the trend might change. People who used to default in the past might be a different set of people altogether now, right? So hence I keep uploading the data as and how I get new customers. I add those customers to my existing model. I'm going to once again run the model to get the latest information. Abhilash says, if final model is built and if any new attribute is added over time, then we are going to classify that person as good or risky based on the historical data. And as in how you progress, right, you will get to know whether a particular person or the person whom you have given loan, did he pay on time or did he default? If he defaults, again, that's a new data point for you. So that is the reason why this is called as machine learning, basically. So you keep enhancing your model. You not stop anywhere. Based on your changing living lifestyle, whatever be it, you keep proceeding further. So let's use our model and predict. We have done that. So let us do a hands-on now since we have less time. I've been taking few queries, right? So here are few real-life applications post which I'm going to show you on R. How do we run this particular model decision tree technique? So finding out whether a person has low-grade cancer cells or high-grade. So you can check that whether whether the cells within human body are normal or are they showing tendencies of cancer based on historical data. You can do so. Credit card transactions. If you do a credit card transaction, should a customer care person call you and check before approving the transaction, right? That's another thing. If you have a newspaper, if I'm going to scan that, or if you have online provision for that particular newsletter, we can read the entire thing and classify the news as finance news, weather news, sports news, so on and so forth. That is also a typical classification problem. Obviously, there have been a lot of questions which I've been answering of late, but let us quickly run this in R and see how it works. So I have a particular data set called fraud data, fraud check. I'm going to load this fraud check into R, and this is the very command which we use to read fraud checks. This is a CSV file. I'm going to load this into R using this command read.csv. And I want the header information, meaning the first row which has the heading information, I want that. And I'm going to read this and I'm going to load this file which I'm going to read into this fraud underscore check. So I run that and I see that there are 600 observations of 6 variables. If I click on this, it's going to show me the fraud check data. There we go. We have 600 observations, meaning we have 600 rows here. And we have 6 variables. That means undergraduate is 1 variable, marital status, taxable income, city population, so on and so forth. I have 6 variables also. Once I read that, I'm going to attach this. Now I cannot go line by line and explain each thing. So few things I'm going to skip in the interest of time. Head of fraud check. So this data set is uploaded here, or we have read this data set into R. Then I say head of fraud check. It's going to display the first 6 rows of this particular data set called fraud check. And there we go. We have the information for that. Now that we have a lot of values, taxable income here, 68833, 33700, 36,925, 5190, so on and so forth, right? So I'm taking 33,000 as, or here 30,000 as a number where I want to benchmark. If a person has a taxable income of less than or equal to 30,000, I say risky, otherwise good. This is just for classification purpose, that's nothing else. Just to demonstrate for you all. So now I have assigned these risky and good values for each and every 600 observations there. Now I'm going to build something called as a data frame. So when I build this data frame, now what I've actually done is, to the existing fraud check, I've added another column which says risky or good, right? Based on taxable income. If the taxable income is less than, say, 30,000, less than or equal to 30,000, I'm saying that person is risky. If the taxable income is greater than that, it's good, kind of, right? So just for your understanding, in real world, right, you'll get this complete data set along with the category of good or bad, good or risky. You'll get the entire data set. Since this particular column wasn't there, I just manually created just for your understanding only. Word of caution, right? Take it with pinch of salt. So now I'm just checking the table there. So here, when I look into the table categories, right, I see that 476 entries out of 600 are classified as good and 124 are classified as risky. Now that we have the information on whether a person is good or risky based on the income, right, it makes sense for me to remove this income part. So I'll remove this income column there. -3 means I'm going to remove that particular column basically. So now let me see whether income is there. No. Now if I see names of customer, I do not see the income there, so it's removed now. Set seed equal to 2. I'll not spend a lot of time on this set.seed. This is only used to limit your or each time you generate a sample, each time you take a sample, it's going to take the same sample if I set a seed. That's it. So you can give any number you want for that, 2, 3, 4, it doesn't matter on what number you're going to give it. This is just our command frame. That's it. Now I'm going to divide the entire data set, 600 data set, 600 observations into 300 each. And the 300 which I'm going to divide, I'm going to assign, or I'm going to term that as training data set, based on which I'm going to build a model. The rest of the 300 I'm going to use to test my model, whether the model is accurate or not. So let me check the length of train. You'll see that there are 300. Why? Because I've divided the number of rows of customers into 2. 1 to n rows. I'm taking a sample, right? And I'm dividing that into 2. Basically, that is what I've done. And minus train means all the data points which are not from the training data set, I assign it to test data. And I'm going to look into the length of test there. I get 300 once. Now, training data, I'm going to assign this customer training, whatever data I've assigned as training data set, I'm going to assign it to training underscore data now. Whatever data I've assigned to this variable called test here, I'm going to assign it to testing data. Yeah. So now we have the testing data and the training data. You can also look into the names which are available. That names means nothing but your column names or variable names. Okay, I've just run that. Do not worry about these things a lot. Just understand the logic of your DIM means dimension of training data set. Length means it's going to give me the length of your testing underscore high, which is nothing but your testing data set once again. Now if I want to look into the summary of the data set, we can do so. It's actually recommended that you do this descriptive statistics even before you proceed further. So I know for a fact that I have undergraduate 161 undergraduates, 139 who are not undergraduates, and I have the marital status of people. 105 are single, 104 married, and 91 are divorced. If you have the continuous data, you will have minimum, maximum, first quartile, third quartile, median, and mean values in that. Now, in order to run this decision tree, you need to first install and load this particular package called tree, and there's a command, right, for tree. And now the syntax for running this decision tree is tree, training dataset, category is my Y, right? It's always Y tilde X. You're trying to identify Y category as good or risky based on all the values. That is what your dot means here. You have a dot here, that means I want to categorize a person as good or risky based on all those input values from this training dataset. Remember, I'm building a model based on the training dataset. I've divided the entire dataset into training dataset and testing dataset. So I have. Now, once we are done, we can plot this. Now, this is where I was saying that we can graphically view. So if you want to view the corresponding values associated with that, I've run that command. Let me zoom this. This is so graphical. City population, that was the first root node that was considered. Next, work experience. Within that also it has taken few splits. And then city population was the third split. Once again, good or risky. Then work experience also was considered city population in that case. Undergraduate, yes or no, that was the last value which was considered. Based on how much information each value is giving you. In that way, it has generated a decision tree. If you see city population appears here also. That means based on work experience, once again, you're looking into which value or variable is giving you maximum information. So it's not as simple as we have discussed using our presentation, right? There's a lot of there are a lot of complex things which go in the back. Once I build the model, we need to predict using a test data. Tree underscore model is actual model which we have built. Now I want to predict the future based on the testing data. And what are we doing? We are doing the classification, and the type is class there. Now, if I look into mean of the misclassification error, right? How many times did we misclassify here? The higher the mean, bad is your model. So you can further bring it down, right? It's 0.233 and you can further bring it down. Okay. What's the question? Abhilash has this question. Data analytics and predictive analytics can be done by building decision tree. Yeah, that is exactly what we are doing. Yeah, we can, Abhilash. Decision tree is one such technique, right? Reality might be a different situation, but this is one technique which can be used. So now I'm setting a different seed. That means I want a different sample. Simple. Now I'm cross-validating the tree using cv.tree. Now if I do that names of, I'm looking into size, right? So let me plot this and show you what exactly is being done here. So I've plotted this graph using only your circles or small dots there. If I want both those points and line, I go with the type B there. Now, if you see here at second place, you see a steep bend, right? You see a steep bend there at the second point. So that means if you build your decision tree, it's better if you prune the tree to 2. That's the indication. So I prune it by 2 and I try to plot it. Now, if you see earlier, the graph had a lot of splits. Your decision tree had a lot of splits here. Now the number of splits have reduced and it got reduced to second split basically. So let me also add text around that. Now this is how you classify. This is a simple model. So you can increase the accuracy of your model. Now I'm predicting using the testing data. And now if I look into the mean value, it's 0.22. It has come down from 0.23. Right? Even small decrease in this mean value means a lot. So this is all about your decision tree. Now off to your questions. So Krish has this question. How is the job market? What kind of jobs would you apply for with this knowledge? Yeah, Krish, so you become a data scientist, basically dealing with a lot of data. Yeah, Krish, I'm done. So you can apply for a job, you know, along with this data mining, you also need to learn statistical analysis and forecasting. And then you can claim yourself as a data scientist and start applying for those kind of positions. And only based on data mining also you have a lot of jobs available. Goer has this question. Like most of statistical models, we have certain level of confidence. So do we have similar confidence level in this model as well? What is percentage of confidence with which I can see outcome of models? So, you know, each model has a different way of evaluating the accuracy, Goer. If you use your regression models, probably AIC values or your R square value, if it's your linear regression, things like that can be used. However, in your decision tree, you use this mean. I've done that mean, right? You can use that value to actually gauge the strength of your model. What about freshers? Will they ask for experience? Data scientist as a job itself is pretty new, right? It's very, uh, it is at a very nascent stage. So I do not, I don't think people are going to ask for a lot of experience. As such, there is a lot of crunch in the market. There are a lot of requirements. Demand supply ratio has screwed up. So there's a lot of demand, but the supply is limited. Manish has this question. From the example, it appears that we are looking at constructing decision tree with leaf node not being too deep. Like here we see leaf node at depth of 2. That's a decision that you take, right? If that's a cost benefit analysis decision that you take with the management. If you feel that there are far too many rules, and if you feel that the number of misclassifications have to be brought down or the accuracy of the model should be further increased, then you do so. Or if you're happy with 0.233, these many are not matching, then that's okay. That means, what does that mean? On an average, these many are not being classified properly, correctly. If you want to reduce that further, you can do so. Or if your management says, hey, it's not 0.22, I want 0.1, then probably you'll go with a different technique altogether. So it all depends. Oh, no, Manish, there is no recommended range for the mean as such. Gaur has this question. Can we have the PPT of this webinar and data files on stepwise our instructions? You need to check with the Edureka team. At the end, right, once you close the session, you'll be thrown a pop-up to take the survey question. And in that, you can mention that you require the PPT and the R instruction. Probably they'll accommodate. But the recording, I think, should be made available to you. Is testing underscore high the threshold value is what Abhiraj said? No, that's not the threshold value as such. I'm just comparing it, that's it. So let me show you what we have done in testing underscore high. One second, Ablash, while I take your question. Nehal has a question. Is it a good idea to switch from a reporting job profile like a microstrategy tab? Yeah, that will be the most logical shift for you, Nehal. If you're in MicroStrategy or data visualization tools such as Tableau, right? It would be the most logical way to move on. Is the IG calculation, Arun has this question, is the information gain calculation present in your code or is it part of library? It is part of library tree, Arun. Devapriya has this question, can you show if new data enters, how will it be done? It's predict, that's it. So Devapriya, this is a command that you can use, right? Predict is a command, and then here instead of testing data, right? I use that new data. I save the new data as say CSV file. I'm going to load that. If the new data that I'm loading is called as new data, you give the new data, and this is the command predict, and it's going to predict the outcome. Are there any other tuning parameters other than pruning? There are a lot of other parameters which can be used, but pruning is one such technique. Manohar has this question. May I know what's the prerequisite to learn this course? There's no prerequisite as such. Even freshers are free to join this course. You'll be taught right from the basics, assuming that you do not know anything. But there are a lot of job opportunities for freshers as well. You can just do a search on your job portals, right? That will give you a clear indication on how much is a requirement. There's a lot of requirement, basically. So even before I forget, one last question from Abhilash. So category of test, your test data, right? From that, it has just taken a category. So what is a category here? This is a category, right? Good or bad. So link for this course would be shared with you, Krish. It will be shared with you. And guys, do not. Okay, Nehal has this question. While building the data tree, is it possible to plug in a custom logic, like if the bank gives loan has a preference for married people or something? You can tweak that, Nehal, but ideally, what would you be doing? You'll be tweaking the logic of the decision tree itself. Decision tree as a technique has emerged based on a lot of scientists, mathematicians who have spent a lot of time on that, right? So you'll be basically define that logic if you try to change. You can do so. If your understanding is far better than the model, you can do so. All right, friends, thank you for attending this webinar. And this recording will be shared with you. The moment you close the window or you log off, you'll be given a survey. You'll be thrown with a survey window. Just fill all those details, and whatever question you have, please mention in that, so that you will get appropriate responses to that. Thank you, Gaurav. Thank you, everyone. Have a great day. Thank you, Arun.